Welcome to Brain Vision.
In this problem, we have a beam that has a little bit of a unique support structure. On the left end, we have basically a system where it allows the beam to slide up and down, but it prevents it from twisting or from bending at this point. So we have a zero slope. We have a applied moment at this end that will constrain this thing from not being bent at this end. And at the other end, we just have a roller. So we have an unknown moment reaction force here and an unknown force here. We're not given actual values in this problem, so we can determine that this moment is actually 1/2 omega naught times L squared, and this load is just the total load applied because we have a uniform distributed load. That's omega naught L. Now we can draw our shear, and in this case we have, if we plot V over omega L as a function of x over L, then the slope of this line is -1. And so V is minus omega L x, minus omega naught x. So we have, then if we come over here, we can see that the slope of this curve is actually the value of this curve. So up here we have a zero slope, and down here we have a slope of -1 if we plot m over omega naught L squared and x over L. And we want, basically, if this is linear, then this is quadratic. So we have a parabola that comes this way. And then we can also see that, we started at 1/2 for this value. And we can see that if we integrate this, we're going to get minus x squared, minus x squared over 2L, and then we need to make sure we meet our boundary condition here, so that gives us this constant. And so we can see that, in fact, that the derivative of this is this, and again we have an extra L here, so the derivative of this would be x over L squared, but then we need to multiply through by L, so we get or minus x over L squared, so we get back to this. Again, this is the derivative of this.